Hey, hello everyone. Today I'm going to talk about the fourth Leetcode questions, and it is a median of two sorted arrays. So you are given two sorted arrays, nums one and times two, and sets of I and n respectively. So you need to return the median of the two sorted arrays. So look at this problem. You give an example, such as in the first example, nums is 1, 3, and nums 2 is 2. So the median of the two merged arrays, 1, 2, 3, and then the median is 2. And as for the second one, 1, 2, 3, 4. So you plus 2 and 3, you got 5, and then divided by 2, you got 2.5. So therefore all 0, then you return 0. And let's look at this. And it should tell you that the overall runtime complexity should be O log n plus n. So look at this. This is a very difficult question. Why is difficult? Because have you heard of merge sort? And as for the merge part, you only need to merge two sorted array, and it will only take you about actually on time. And I think this also work for this problem. It's not very complicated, but the question asks us for log n, so that's where the difficulty come. So let's think about it, how we can solve this problem. And actually, if you look at the algorithm, it is something like log n. You need to think about something. Have you ever come up with something? Yes, of course. It is what we call the binary algorithm. So I will draw some pictures for you. Okay, so we need to reconsider what is the definition of median. Median is some numbers that in the real middle of an array, and we draw these two arrays. I will show it for you and demonstrate this is nums 1 and this is nums 2. Okay, so we divide each of them into two parts. Num1 have m elements and num2 has n elements. And as for num1, this one is from 0 to I minus 1, I mean the index, and this one is from I to m minus 1. So the same for nums2. All right. And in the left part of the nums1, we can have actually I elements, and for this one we have I minus I elements. As for nums2, we got j elements, and this one is for n minus j elements. All right, so what should they be when we merge when we want to get a new arrays, and this is the middle, that's what we need to get. Maybe if this one has maybe even integers, then we need to return something plus something and then minus 2 if other integers, so we just return the middle. All right, okay, so here we go. What we can get from these two arrays. Well, actually, when you go to this, what is the median? Some in an array, the median, the numbers left in the left of the median and the numbers in the right of the median, they must have the same size. So what can we do about this? It means I plus j. This is like this space, and this will be equal to I minus I plus n minus j, which is correspond to this part. So this is an equation and it should satisfy. And also, what can we do about it? Because when we get these two arrays together, as for the nums1, this one, which means nums1 I minus 1, it must be less or equal less than nums2. This is nums1 and this is nums2. J, all right? And also by symmetry, nums I must be bigger than nums2. j minus 1. So that's what we need to satisfy. And by this, we can get our algorithm. So we just need to use 2 pointers and from left to right. And then that's what we binary search. And binary search actually it has a sorted array such as 1, 3, 6, 10, 11. We want to find something from left and then from the right, we got into the middle. And then if someone such as this is maybe we want to find this one, this is our target, and mid if mid is minus and target, and then we move left to the mid plus 1, and then we do that. So it has log n time complexity. So hope you can understand what this algorithm works, and then we are going to do our code. And one more thing that we need to make an induction that what is the relationship between I and j? So j is actually m plus n and minus I. Okay, I mean this, which means this is also the half length of our new array actually. So we also need to consider that m should be bigger than n. If not, in our following code we got array index out of bounds, maybe some numbers -1, which is not allowed. So firstly, as for our code, firstly we need to know whether to check if m is -1. If not, swap m and n. I mean the length of numbers 1 and length of number 2. Of course, we need to also swap the arrays itself. And then second, we use a while loop, and in this while loop, I mean, such as we called ME and MX, and in this while loop, we're gonna do something. What are we gonna do with this while loop? We need to know whether that's what we use binary search. All right. So, and also we need to know if m plus 1 is is an odd. If it's odd, just return the middle. And if not, I mean, we also need to initialize another variable and then return to such as this one plus someone and then divided by 2. And finally, we will get our result and then return 0 if none of this happens. So I will implement my coding in this, and here we go. Okay, as for the first part, we need to firstly change our m and n. All right, so int m is the length of the nums1, and also n is the length of our nums2. Actually, we should put this in the second line, be much more clearly. And then if m is bigger than n, that's what all we want. So we need to build another temporary array and make it should be the same value as nums1. And then nums1, it should be nums2. And also nums2 should be array. And then we also need to temporary, and this is m, and m should also be equal to n, and then n should be get the value of temp, so that we have changed the value of m and n, and we guarantee that m is less or equal than n. Okay, so in this time, we got to define two variables, int I mini, this is start from 0, and mx, it should be start from m. Also, we need to define the half length of this new array. It is actually m minimum plus mx. Then we gonna go in our while loop. If I is smaller or equal than ms, well, we need to consider, we need to notice that this one must be less or and equal, not less. All right, so pay attention to this, and then we int a variable called I, and I is actually I minimum plus I max be divided by 2, and also we need to initialize a variable called j, and this is half length minus I. That's what we have already done in our induction. All right, look at this. Okay, here we go, and then we need to check if I is minus than I max. I mean, this should be guaranteed. And also, we need to know if I is very, very small. What do you mean? I is too small. Numbers 1, I is less than numbers 2, j minus 1. Oh man, there's a problem. And in this time, we need to move I minimum is I plus 1. And if in the another situation, if I, of course, we should guarantee I should be bigger than I minimum. And also this time nums 1, I minus 1 is bigger than nums 2, j. And in this time, we're gonna make our max is to I minus 1. Okay, if not, I mean, it doesn't matter. So what can we do? Actually, we need to do something like, well, what can we do about that? Oh, actually, we should, I mean, this time when the I is very suitable, I is appropriate. So in this time, what we gonna do? Actually, we need to do some, oh, sorry. We need to define a variable, and that's what we return. Left max, actually, and this will be what? Think about that. What should it be? Left max. Oh, it should be initialized to 0. And if I is minus to 0, what does this mean? I minus 2, I is 0. I mean, in this time, we can draw a picture. If I, this is nums 1, I is only too small. So this is nums 1 and this is nums 2. Okay. And then left is to this one. Then what does this mean? This is j minus 1. Okay. So, okay, wait a minute. And okay. So left max is equal to nums 2 j minus 1, and else if j is to 0, what do I do? Then left max is to nums 1 I minus 1, and if not, we need to, I mean, so we need to get the maximum of these two values. Okay, and it is nums 1 I minus 1 and nums 2 j minus 1, and then we're gonna finish with this. Also, we need to, if I mean, the numbers of in the new array, or the sum of the numbers in nums array 1, number 2, the sum is odd integers, which means that m plus n, this is mod by 2 is 1. So we just need to return left max actually. And if not, I mean, we need to initialize a right minimum. This is similar function with left max, but this one get the in the right side of the array. And also, if let this be, if this is n, I mean, in this time, we should make our right minimum is nums1, oh no, nums2, g, actually. Because, you know, actually, when we want to draw this, like in the first one, this should be something like that, and then it should be this part, and this part is j. Okay, so let's do this. And also, if else if j is to, oh, I'm sorry, this is m. Oh, m. Okay, if j is to n, and wait a minute, floating control. Okay, so we're gonna do, of course, we want to find nums1, I. All right, if not, also we need to get our right max to be the max dot minimum of our nums1, I, and the nums2, j. Okay, here we go. So finally, what we want to do, I mean, we want to return actually left max plus right max, because if it has you know, even integers, so I mean the number of the new array is even integers, you need to combine these two. I mean, you need to plus the first middle and the second middle, and then such as 2 and 3, you got 2.5. That's a real medium, although 2.5 didn't exist in this. Okay, you need to point by 2.0, not 2, because it will be a floating number actually. Okay, so look at this double, right? It returned double. And finally, we're going to return 0 if we've done none of this. So let's look at the result. Hope it works. Oh God, what happened? Not a statement actually. Oh, sorry. I think this should be else if. This should be walk. Come on, let's see that. Oh man, that's not good. What happening? Oh, this should be actually G. Oh, half length. This should be mx. Actually, we have just defined that this should be m plus n, and then what we're gonna do plus 1. I mean, by 2. Okay. Here we go. We'll see if it works. Yeah, we defend 100%. And so, as for this question, what is the time complexity? Actually, we have just analysis. It is the time complexity is O log m plus n, because in this loop we're gonna see this. All right, we just get the maximum of this. So that's our time complexity. What about space complexity? Do we need actually? It seems that we didn't actually use extra space, O(n) space. So I think it should be O1. Am I right? I'm not very sure about that. Okay, so that's the whole question. I mean, this is a quite a bit complicated and difficult problem. You need to consider this for a long time, because you need to know the true meaning of what the medium do. And in this way, you can, you know, use a binary search, which is very helpful. It is very algorithm efficient and fast. So binary search, keep in mind. And okay, that's all of my viewing of Leetcode4 exercise. And I will continue to do one by one. And you know, actually, in the last about a month later, I will have a Facebook internship interview, and they will get some legal exercise. Most of them are medium difficulty, but actually I want to challenge myself to do some difficult ones. So just never give up. You're just never gonna give up, and I hope you can understand this problem, Leetcode4, and I thanks for watching. I appreciate if you could subscribe me and you know, yeah, that's right. So goodbye. I will see you next time. Okay, bye.